the process that I'm going to be doing is basically the thing you have in between acquiring the data and analyzing it. Okay, I'm simply going to organize, I'm going to clean my data, and what I normally do for this is starting by merging my data. Now, whenever I merge my data, what I normally do is I take the data from the spectrometer, I'm going to place it on a folder, and in that folder, depending on how your instrument works, normally it's going to place all of the different samples in different files. This is going to be a bit tedious since normally what do? We go file by file and we copy and paste it into a single Excel sheet, right? And in that way, we can have all of the files in only one Excel sheet. However, there are better ways to do this. Fortunately, I managed to make a script that allows you to merge all of the data. Now, this script specifically works for .csv files. If you have .txt and .sbc, not going to work for those specific file types. However, I do have one for txt, but I do not have one for sbc. This one I do not have at the moment, but hopefully I will work on it and you'll see it on the page in the future. So we're going to be working, assuming that your spectral data goes into different files that are in the CSV format. Now, for that specific thing, the first thing that you should do is you open at least one of your samples and see what the tendency is or the organization of that specific sample. And what do I mean by that? What I mean is how the information is organized. For a QCL spectrometer that we use on the lab, the data goes from row 1 to row 13, basically giving the information regarding the different parameters and dates and all of that for when you acquire your spectrum. This is useful information. However, if you just want to have an Excel file with only your data, normally you don't want this specific thing on your data. In addition to this, the specific information that gives the QCL spectrometer, it gives you the spectrum of the background. Gives it from row 14 to row 291. Reference being the environment where the analyte is going to be at when you take your measurement. Normally, you just want your analyte, depending on what you want to do, right? But normally you want your analyte. So you first take a measurement of the environment so that when you take the measurement of the analyte, the program will subtract that specific information of the environment, or it might divide it. In this case, it divides it. However, this specific data, I do not want it when I just want to have all of my analytes in my Excel data. Why am I going in depth with this specific thing? Because if I want to create a program that basically merges all of my data, I do not want the information that goes from row 1 to row 291 for this specific sample. Okay, so that's what I'm taking into account. That's what I'm considering when I create this specific script. Now, here you have the information more detailed, the info, the background data or reference, and the analyte data. If you do not use the R language program that I'm going to be using, you can go to our webpage, go to the files/info for research, and in that webpage, you can go to the Learn R language webpage. In that specific webpage, I have information from how to get started with R, which gives you the link to download the program, the link to download the interface, a lot of useful tools for the R program. I have a column with all of the libraries that you probably will use whenever you do a program, and some of the scripts that I have written. And specifically, I'm going to be using this specific script, which is going to help us merge all of the .csv files. Here's the one of the txt. The SVC will be coming whenever I manage to do that one. So if you go to the .csv file, you're going to see instructions showing how to use this specific script. And I'm trying to do that for all of my scripts, since I know that basically the person that created the script is the one that knows how to use it. So in order to avoid that problem, I'm trying to go in depth with how you use the specific script. So here you have the information. I'm going to be giving it to you in this webinar, so there's no problem with that. So below that information, you have the overall code. And what you do in R specifically, it's basically you select all the text, you hit copy, and then you print it, you paste it, on the R console. And in that way, you basically ran a script. So simply you do the necessary modifications, select it, copy, paste it, and that's all. And you run your script. Okay. So this is all the things that you need. Now I'm going to be talking about the code itself. In this case, the first part of the code, you're not going to touch it. It's basically just importing all the necessary libraries you need to use the code. Now, the ones that have the box, the red boxes, those are the parts that you need to change. Specifically, the folder path is going to be the path where your folder is. How can you know that? You can basically click on your folder and then hit right click and go to properties. And in properties, you're going to see this option right here where it says location. And where it says location is going to have the path where the folder is located. Once you have that, you have to change all of the slash characters and place 2 slash instead of 1. If you do not do this, you're going to have an error on R. So please place 2 slashes whenever you are giving more information on the different parts where your file is located. Now, after you go to the desktop file location, you have to place the exact name of your folder. Okay, you have to put the exact name of your folder. So you can basically copy paste the name there. Once you do that, you're going to finish the quote. Well, you can't see it here because there's 2 at the right or to the right. But you're going to finish the 2 commas, right? The quote marks. And there you have your file path. For your output path, you can place wherever you want, right? The program is going to merge all the samples and it's going to create a new file. And you have to basically tell it, okay, so where am I going to put this file? I keep it simple. I go to the desktop and then I simply put the name of the file. And since it's going to be a CSV file, you have to put the .csv at the end. Okay. So once you have those 2 things, I'm going to place the date that my files have. This is an option that's specific to the instrument that we use. The instrument normally places a specific name for each sample, and they all start with the date. If your instrument does not do this, you can simply eliminate this function from the overall script. But if you have that option, you can simply place the date here and it's going to eliminate it whenever you have the individual columns with the samples. Okay. Now, what I was saying previously is that our data in my specific folders, the files, it starts from row 292 onward. So everything that's from row 1 to row 291, I do not want. And that's why I placed this thing here on the if loop. I placed that all of the rows that are from 1 to 291 are going to be deleted. Okay? The 301 part right here, that was a mistake by my part. That's simply on the comment. The comment does not affect the code. However, instead of 301, I would place 291 there to give context to what I'm doing when I change this part right here. Depending on your files, if you have all of the information that you need since the beginning of the file, then you don't have to do this specific part. You simply run the code without eliminating a specific number of rows. And if you have a different number of rows to eliminate, you simply change the 291. Okay. So once you have that, you're going to select all of the text using Control A, and then you're going to copy all of that text using Control C or copy. And with that information, you then go to the R program, you hit open, and in the R console, this place right here, you're going to hit Control V to paste the script. And once you paste the script, the program's going to do its thing and going to run your script. And after it does that, it's going to create the new output file, which is named output.csv, the way that we did when we made the output path. The script is going to place all of the samples on column. The samples are going to have the name of the file that was created for that specific spectrum. And it's a bit tedious, specific for the file that we're working with, because it gives you a couple of numbers at the beginning, which change with each sample. And that specific numbers are referenced to the time, specifically the hours, minutes, and seconds. If they all vary, you cannot basically remove it unless you do it manually, right? So what I usually do is that once I know the numbers of each of my samples, I have a notebook, and in my notebook, I place the name that the instrument gave the sample, let's say sample 1, and I create a column telling me and the other person is going to see the file that sample 1 equals a sample of TNT, for example, and is the first replicate. So you can either keep this on your notebook or you can change each of the columns. If you change the columns, it's not going to be that tedious if you only have replicates, because you made the first one TNT01, and then you simply click and drag to the right, and you made all the other replicates. And it's a lot more easier. If all of your samples vary by analyte, it's going to be a little more time consuming to place the column. So now that we had all of our data merged, we're going to start organizing our data. For this part, I'm going to go to the first part of my Excel file where is the A1 cell, which is the A column and the first row. And clicking on that specific cell, I'm going to click and hold Control Shift and the downward arrow or page down arrow. So if you click that, you're going to basically select all of the information that goes from that specific cell that you clicked on and all of the things that are below it. Very, very useful to select a lot of data quickly. So once we do that, we take all of the data from the first row to the last one, and then we basically click and hold Control Shift and the right arrow, and we can take all of the information that's from the left to the right. If you use these shortcuts, you're going to select the data in no time. It's basically going to take you like 2 seconds. And it's very useful because it's different than using Control A. Because if you use Control A, you might select all of the rows and all of the columns on the Excel file. And normally you just want the columns where the samples are. So that's why I use those specific shortcuts. Now, once you do that, I'm going to copy all of the data, Control C. I'm going to create a new sheet, and I'm going to click on the first cell of the sheet, right click and hit transpose. And this is going to allow me to make all of the columns of the data convert to rows and all of the rows convert to columns. And by doing this, now I have all of the samples placed in rows, and all of the wave numbers placed in columns. This is very useful when you want to organize your data. It's very useful for certain programs. Normally the programs run with the samples in rows. Some other programs might not, but the ones that I use normally use them in rows. So I'm basically adapted to this specific model, right? So in addition to that, you can then click on the column B, the specific area, right click and hit insert. And that's going to create a column at the left of column B. And since you created a new column, they go in alphabetical order. So the column B now turns into column C because you have a new column between it. I'm going to do this 3 times, and I'm going to create 3 different columns. They're going to be named sample number, class, and label. Sample number is basically the number of replicates. Class is going to be the different analytes or classes that I have depending on what you're doing. And label, it's basically the information you're going to give to the legend of the graph when you're going to be graphing it. So these are the different columns that I have. I'm going to show you how you can fill them in no time. Firstly, what we can do for the sample number or replicate is we can write the following equation. We can write right, and in parentheses, I'm going to place the cell that I want it to take the information from, which is going to be A2. So I'm going to put right A2, and then I want it to take the first 3 characters from the right of the text, which is what the function does. Okay, so I want it to take the first 3 characters at the right of the name that we have on that specific column. It's going to take this one, and this one. Those are the 3 characters at the right. So once I hit enter, it's going to create this specific text right here, which is the first 3 characters at the right of the text. And if you hit or double click, if you double click the lower right part of the cell, you can basically copy that function to all the other functions in that specific column. And in that way, now you have automated all the numbers. Now you might say, Edwin, it looks a little bit weird, right? How you have this, this, and this. Well, that's specific to the way the sample file was named. That's specific to how the sample was named. I'm going to show you how I get rid of this specific thing, but it is a specific case. What's the best thing you can do? I'm going to show later. But for the meantime, I have this specific part for all of my samples, and I want to eliminate the underscore. I can do this by using the opposite function, which is going from the left to the right. So I'm going to put equal left. In this case, I want this cell, which is the B2 cell, and I want to take the specific 2 characters for the left. And in this case, I'm going to end up with E and 1. And you might say, why did you bring up the E? You could have just used 2 characters at the right. I placed the 3 characters because I have numbers that go beyond 9. And those numbers do not have the E. So this is a problem that happened because there was no consistency with the amount of digits. If you have your digits like this, they go to 0, 9, and then 10. If you put 2 digits, you're going to have this result. If you have 3 digits, that means that you have samples that are from 1,000 onward, then you need to put more digits and so on. So it depends on the amount of samples that you need for your project. Now, one thing that you can do to automate this even further is to control the sample name for each sample. For my specific instrument, you cannot change the sample name. Or at least, if you change it, it will still place other text at the left or the right. So it's not going to make a difference. It's better to have the thing that it had as a default. But if your instrument has the the capabilities of only placing the thing you give it, then I recommend you use this format right here, where at the left, you have the analyze that specific sample that you want to analyze. And at the right, you have the replicate, the amount of samples that you're going to take for that specific analysis. I wrote this one, replicate. Okay, so if you use this specific format, what I'm doing is the analytes always will have an acronym that has 3 characters. They will always have an acronym with 3 characters. You can simply use left, the cell where you have the text, and you put 3, and you're going to have the name of the analyte. And for the replicate, you use the 2 digits, and you put right, A1, 2 digits, and you have the replicate. As easy as that. Okay, so this is what you can do to even further optimize the naming. Here's an example. I have TNT hyphen 01, and then I have another sample which is RDX01, and I have another one which is PTN01. Now PTN usually has 4 characters, but since I want to be consistent, I only use 3. That's the one, PTN. I use PTN. Okay, so if I do this, I simply use left 3 characters, and I have all of this made in seconds. And then right 2 characters, and I have all of this in seconds. So I'm showing you how that specific decision can impact how quickly you can organize your data. Now, for the label is basically the name that you will have for each of the samples in your legend when you do the graph. For the label, what I want is the name again and the replicate. Since this is a bit more complicated and not all the things that I want, I'm going to mix these 2 names, sample and one. How can I do this? I use the concat function, which is concatenate, the ability of merging more than one text. In this case, I'm going to put C2 because I want the name to start with sample. And I'm going to put in quote marks a space, just a space. So I basically place the first quote, I hit the space bar, and I place the other quote. And this is going to put a space in between the 2 texts. So I'm going to do that, and then I'm going to place the B2, the B2 cell, which has the 1. And if I do this, when I hit enter, what's going to write is sample 1. It's going to write sample 1. It merged the 2 texts and placed the space between them. And you hit double click the right part of the cell, and you will do that for all of the other samples. So once we have merged all of our data and we organized all of our data, the next part is to graph the data. So what are we going to do? We're going to select from the label column, starting from the label column, all the way to all of the spectra, which we can hit, again, Control Shift down, Control Shift right, and we have all of the data. We can do that, and then we're going to go to the insert part of the menu. We're going to go to the chart part of the insert, and then we're going to hit scatter with smooth line. Okay, so I'm going to choose this specific graph right here. Basically, it's going to put all the spectra with lines that are going to be smooth. That's all it is. If I did that, you will see that all of the samples have the name of the samples, which are from sample 1 onward. If you had a name for the samples, TNT, RDX, if it was like NaOH, etc., then it will have the name of those specific samples. Normally, it's not good to have a lot of samples in your graphs when you have a legend, because it's basically too much information. You're not going to do a lot with that. I'm placing it here just so you know how you would place it if you had that specific scenario. But if you don't, it's a lot more easier because it's just doing what I'm doing, but with less names on the bottom. So I'm going to use a lot of names so you see how I work around. So this is the information that you're going to get. This is the graph you're going to get. It looks ugly. I'm going to show you how you can better the graph, how you can improve the aesthetic. So what we're going to do is place the legend to the right. So I'm going to click on the plus sign on the graph. I'm going to go to legend, the arrow on legend, and I'm going to choose right. And that way, the legend goes from the bottom of the graph to the right. And now it looks a lot more better. After that, I'm going to insert the axis titles. We need to know what each axis represents. So I'm going to click on the plus arrow again, and I'm going to click on axis titles. And then I'm going to place the name for each of the graph, for each of the axes. So I have intensity for the y-axis and wave number for the x-axis. The information depends on what is the spectrum that you're analyzing. So the other thing I'm going to do is change the style of the font and all the parameters around it. What I prefer is using Arial, size 14, black, and bold. Now, I specify that the color is black because by default, Excel does not give you a black color for your text. It gives you a gray tone. And normally it looks, I don't like how it looks. It's a bit unappealing. So I prefer using the normal black color for the text. So once you do that for the axis, you can do that to all of the text of the graph. And if you compare both, it looks a lot more professional for the one on the bottom, or at least it looks more understandable. You can actually read it better. You can read it better. I prefer using the black color, the bold, the Arial 14, all that. So once you do that, you're going to resize the graph. Now for resizing the graph, you can simply pull left to right. You can pull up and downward. And I'm going to resize it in such a way that will allow all of the samples to have their legend, because I have over 95 to 96 samples. So if I resize it, I will manage to place all of the legend on the graph. Now, this looks ugly, right? Because it's a lot of legend. It's a lot of samples. Normally, you would have something that allows you to minimize that amount of legend. In this case, I'm placing it all so you see how you might manage it, okay? However, this is how I scaled it, and it looks a bit better than what we have here. Now, what we're going to do is scale the axis, the y-axis and the x-axis. What we do for that is we click on a specific axis, in this case, the one on the bottom, the x-axis, and then we're going to click on the axis option right here and go to axis options below. In here, the bounds are basically the left and the right part of the axis or the x-axis. So I'm going to place a minimum value, a maximum value, and then in the unit, I can place the values that go between those two ranges, those two edges. I'm going to show you how I do this. It's a bit weird, but it's a process that I personally have found very effective. What I do is, firstly, it's the basic one. I'm going to basically eyeball where the maximum and the minimum is for all of my information. And how do I do that? I do it in such a way where the less amount of blank space is on my graph. Okay, I want the blank space to be as minimum as possible so that we can basically use the more space available. So when you're dealing with spectra, it's a bit more easy because the x-axis has a specific number of wave numbers, and it goes from a minimum wave number to a maximum wave number. So those are going to be your minimum and maximum. A lot more easy with spectra in that case. The y values, though, you have to measure them in order to have the specific sweet spot you want. So you have to basically eyeball it. In this case, I would say that 1.6 would be great. If it basically looks too close to the axis, then I would put 0.61 or something like that. Okay. But the thing that I'm going to show you is how I manage to organize the amount of numbers that I have on the axis. In this case, what I have preferred is having a maximum of 6 major ticks. The major ticks are the ticks that go on the numbers in the specific axis. I prefer using 6. If you go above it or below it, I personally do not like it. So I'm sticking with 6. Now, how do I calculate the amount of space I need so that they fit perfectly on the graph? What I do is I calculate that. And how I calculate it is basically placing the maximum value, subtracting it to the minimum value, and then I'm going to divide it by the amount of ticks I have minus 1. Normally, it gives you a value with 7. If you put 6, it has like a degree of freedom that you have to subtract. So if you do this, now you have the increments needed so that the graph basically starts and ends with a number at the edges. And that is completely, that is satisfying to me. Like, I need to do it like this. Is it necessary? Depends on basically the place where you're basically doing your graph. For me, this is the best way to do it, and I preferred it 100 times. What we can do with the major ticks is then we can divide it by 2. And if we do this, you have the minor tick, which is basically going to have 1 tick in between all the majors. If you want to have more than 1 tick, you can also calculate that. However, I prefer to have only the one in the middle. So once you have that, you can then place the tick marks by going to the tick marks area, major type, and hit outside. And you can do the same one for the minor type. You go to the specific box and you put outside too. And now you can see the tick mark. However, they're not that clear. Why? Because the graphs are made with a gray color that basically does not have that much impact to it. I don't like it. What am I going to do? I'm going to change it to black because it's a lot more visual. It looks more, it has more contrast with the background. So I'm going to click on the y-axis and I'm going to do the same. I'm going to scale it. Here you have the information I need to scale it, the same process as before, only that this time is for the y-axis. And after I do this, before I do the part of the black lines, it is important that you know how to format the numbers depending on your data. So normally for wave numbers, we usually do not put decimals next to them. But when you put decimals, it's to represent the specific precision of your instrument. So it's very important. However, when we're talking with Spectra, sometimes people do not put the decimals. You can just place the whole number without the decimals. And how you do that is by going to number, then you hit on the category, you place number, and the decimal places, you put 0. And that way you have the whole number for the wave numbers. For intensity, I usually place 2. So after doing that, after you have the numbers placed accordingly, then I'm going to place the black bars. So I click on the entire graph right here. I clicked on the entire graph, and then I went to fill in line. I went to border, and in border, I placed a solid line, and that line is going to be black, and it's going to be with a width of 3 points. Depending on the width is the amount, of width of the line. 1 is like this, 3 would be like this. Okay, it's a lot more thicker, and I prefer it because it looks better when you're trying to show your graph. So I basically use 3 points for everything. You can repeat the steps, but going for each axis, and then you can remove the guidelines. Normally for Spectra, you place guidelines if you want to analyze the spectrum. But if you just want to show it, you do not put the guidelines. So I did the same thing for the tick marks right on the axis, and now you can see them. Now they are visible. Now they are visible. Everything looks a bit more polished when you put the black lines, when you put the black text. It's very important to have that contrast with the white background. Okay. So after doing that, there's another step that's very, very beneficial. You click on the entire graph, you right click it, and you click on Save as Template. This is an option that I cannot believe that I did not knew for all of my bachelor's degree, and basically since like this year, no, last year, but like in December or November. You basically click Save as Template, you place the name that you want for that specific template, and you click Save. And what does it do? What it does is that if you have another graph, imagine that this is another graph, right? You're going to click on it, you're going to right click on it, select Change Chart Type, and in that option, you're going to select the templates area. And in the templates area, you're going to select your specific template, the one you created. And when you click OK, you're going to have the same aesthetic as your previous graph. I cannot believe that I did not know that this existed. This is amazing. I love it. The only bad thing about this is that it doesn't give you the access names, because it's going to, rightly so, it's not going to assume that you have exactly the same thing. So it's not going to give you the names for this part. It's not going to give you the names for for the labels, but it will maintain the aesthetic of the table. It's going to save a lot, but a lot of time when you want to merge, organize, and then graph. If you use all the tools that I showed today, you'll be able to do all of these steps in just one day, in like an hour or half an hour. If you use the conventional way, it might have taken you several hours to do the entire part, to do all the organize. So I hope this was a great, it was good information for all of you. I forgot the word. Thank you for your attention. That's about it. That's the presentation. Here you have my business card. Here is the YouTube page for basically our research group. You have a lot of different things that we're teaching. I have a lot of different webinars here. I have one on PLSDA and syncope or chemometrics. If you want something that's similar to what I gave here, which is basically working with spectra, I have this webinar right here, which shows you how to pre-process your spectral data. Now, that's about it. If you have any questions, feel free to ask me. I'm going to stop the recording right now, and thank you all for watching.